Oh, my bad. I was playing a game. I didn't see chat. All right, I'm here. Oh. How'd you do, Kevin, on the test today? Wait, we talked in class about the. Wait, did you ask me that question at the end with the track? Now I was playing Legends of Runeterra. You know that new card game, right? Released. Wow. Okay. So you don't treat my class as seriously then. You've heard of League of Legends before, ZJ? League of Legends. Alright, but we did this in class though, Kevin. Like if if you drop a ball and there is no friction, or you drop a pendulum, if you drop a pendulum from a certain height, what height does it go back up to? Right? It's the same type of question, assuming that you don't lose energy to friction. Oh yeah, ZG. Yeah. Oh man, the being whitewashed pronunciation of Chinese words, terrible. But yeah, with the pendulum thing, the track thing, you go back up to the same height, assuming no loss in friction, because your potential energy, assuming you don't lose energy, your potential energy once you get back up is the same. So it's gonna reach up the same height. Okay. Are you a senior, Kevin? Yeah, the answer was 40 meters. Don't tell the three people that were absent today, though. Was it three? Are you taking the physics regions, Kevin? I can actually just fact check. Also, ZG, it's it's like League of Legends, but they made a card game called Legends of Runeterra. So it's like the card game of LoL. And I can't play League as much anymore because my wrist hurts. Kevin Runoff, the Daedrian's friend. Yeah. There's a Kevin Prasad, right? And he's the bootleg Hearthstone. It's a much better Hearthstone. It's a much better Hearthstone. I played Hearthstone for like a year or two, and that's heavy pay to win. Legends of Runeterra, you can actually do something as a free player. I think I spent like $1,000 on Hearthstone, to be honest. Why can't he just feel better about himself? Just let him say calculus. Just let him feel good. I hope you take the Regents though, Kevin. It's a good statistic for me. Assuming that you keep trying and that you actually study for the physics Regents, it's a good statistic for me. I'm aiming for at least a 75% pass rate. Yeah, probably. If I don't have anything else to do, I'm grading them right after. All I need to do is I just need to take a picture and then I have a grade. Have I ever taught AP? No, it's my second year of teaching. I've never taught AP before. I want to, right? If that means that there's one less class that's not physics, right? If I teach AP physics, that's one less class that's not physics. If I go my second year with still not, yeah, second year teaching overall, yeah, yeah, yeah. And if I go, I mean, I plan on staying at John Adams for the next year. I don't really plan on moving. But if my second year at John Adams High School and I still get anything that isn't physics, I think I kind of want to switch schools. Yeah, I've taught in another school. It's like the thing is, I really dislike anything that's teaching that's not physics. I'm fine with teaching math. Eh, ZG, if I majored in physics and you're asking me, do I have a passion for physics? Think about that for a second, right? Think about that. I'm just teasing you, ZG. Don't take it the wrong way. Uh, 2.1311. It's not gonna be on tomorrow's test. Well, now you know it's fine, ZG. I was just teasing you. Hold on, let me. Of course, I like teaching more. Let me get my USB, and then I'll answer Corday's question. Yeah, okay, you actually don't have to major in physics to teach physics. You can get a certification to teach physics, and it's like passing. The certification is passing an exam. And when I took that exam, the only questions that were on that exam were 100 to 200 college level physics. None of those questions on that test were 300 or 400 level. So it's like the easiest test of all. You don't even have to be a physics major. You can be an engineering major. To be honest, I think I can probably pass the chemistry certification. I can actually probably pass it, and so then I can teach it. Mathematical physics majors. That's actually a thing. Mathematical physics majors. Corday, 2.13 is not going to be on tomorrow, but I'll do it anyway for you. 11. Number 11, 2.13. So it says a child starting from rest, right? So your initial velocity is 0. You reach a speed of 7 meters per second at the bottom of the slide. So what is the vertical height of the slide, right? So here's an easy thing. This goes with the conservation of momentum. If you know what your velocity at the bottom is, and let's say this is the slide, right? It's a slide. You know your velocity at the bottom. Well, then you can calculate your kinetic energy at the bottom, right? So, my kinetic energy right now. Okay. They don't give you the mass, right? They don't give you the mass. So there's another way to solve this. Because they don't give you the mass. What are you guys talking about in chat? So since they don't give you the mass in the problem, but you know that at the bottom of the slide, all your potential energy at the top transfers into kinetic energy at the bottom, right? So you know that your potential energy at the top is equal to the kinetic energy at the bottom. So what you can do is, well, you can equate the two, right? You can equate the two, so 1/2 mv squared, right? And then what you can do right here is you can cancel out the mass because the mass is the same. Your mass is not going to change over time. So now you just solve 9.8. Your height is what you want to solve for, 1/2 7 squared. And then you can solve for height here, right? Okay, Corday? So that's what you can do. So 7 squared is 49 times a half is 24.5. 24.5 divided by 10 is going to give you 2.45 meters, somewhere around there. So the answer would be C, 2.5 meters. Usually the girls are supposed to do that. Yeah. Yeah, because you know your total energy at the top is equal to the total energy at the bottom. And you know at the top of the slide, you only have potential energy. And at the bottom of the slide, you only have kinetic energy. So you can equate those two values, right? Because you know the numbers are equal to each other. So then you just equate the formulas, you cancel out the mass, and then you solve for a height, right? And so, but that's not going to be on the test tomorrow. You good, Corday? All right, good. Yes, it is. How do I feel? I don't really care. People I interact with are, I mean, the only people that make jokes are my colleagues. The science department is, the science department likes to troll each other a lot. So I feel when they joke about it with me, I'm fine with it. Of course, if you don't know the person making the joke, it gets a little bit awkward. It's about reading the social situation, right? Is it fine to make that joke in that social situation, or is it not? I find that a lot of students don't don't have that social intelligence to make that decision. I mean, social, like, not intelligence, like social intelligence. There should be a public speaking class at John Adams. Teach you guys how to speak in front of an audience and collect your dots. A lot of my a lot of my peers at their university, like my 400 level classes, I'm grading them as a whole, mainly because that's you have 25 questions on the uh the thing. No, I don't watch Chinese dramas. Do you? I don't. I never really had a preference to watching Chinese dramas. A lot of my colleagues in university, well, not a lot of my peers in university, then when my 400, 300 level courses, they were extremely intelligent. Right? They were a lot smarter than me. They were a lot more intelligent than me. They saw things like instantly and make connections instantly. But they were really terrible at keeping up a conversation. Some of them, most of them were, not all of them. There were a few of my peers that were insanely intelligent and could hold a conversation, and were really interesting to talk to. But most of my peers just couldn't talk. I've been to China once, yeah, yeah. And I just found that while it would take a lot, I would get the content. It would take me a lot longer. I had to think about it a lot longer. And I felt like rather than be doing research, teaching would be a better role. Well, now I want my master's in engineering. I was pretty anti-social, I guess. I don't know. Uh, you saw a Chinese drama. I know someone who Miss Chen watches a lot of Chinese dramas. She watches both Cantonese and Mandarin dramas. I don't watch any of them at all. You guys actually have questions related to the test? No, I'm talking about. Do you guys actually have questions? I'm talking about Miss Chen, not. No, I'm not married. I'm talking about the math teacher, the Chinese math teacher. Yeah, Chen. Any questions, guys, about the physics concept? As much as I like talking to you guys, I kind of want to help people. If people do have questions. But then again, the only people in this chat are people that are talking. All right, Bessie, ask me. I'm fine with you guys talking in chat. I just kind of want questions, I guess. I'd rather play the card game. Yeah, I do. Couldn't have said it better. Wait, hold on, no, no. Yeah, just ask me a question, Bestie. No, I suck at FPS games. My mouse sensitivity is too high. Question A on 2.14. So a child does 2.4, 2.2 joules of work. So your work is zero point 0.2, right? You compress the spring. If the mass of the toy is 0.01 kg, what's the maximum vertical height that the toy can reach before the spring is released? Your body breaks down the bonds between the. That's what happens. Your body breaks down the bonds, and in those bonds are energy, right? Because it takes added energy to bond two atoms together, right? To have a covalent, whatever, ionic covalent bond. And then it also and once those bonds are broken, it releases energy. And so that's where you get the energy from. Uh so number 8. Oh, I'm doing the wrong question. I'm doing 7. All right, 8. So a horizontal force of 5 newtons. Yeah. I'm doing it. I just went over the wrong question. So your mass is 3 kg and your force is 5 newtons and you have a distance of 6 meters, right? So what is the change in kinetic energy when you move it this distance? And since you're doing it horizontally, since you're moving it horizontally, your potential energy is not you're not changing. You have no change in potential energy because you're not going up or going down, right? You're not changing your height. And then the problem with say is your surface is frictionless. And because your surface is frictionless, yeah, I'm answering your question. You said 8, right? This is question 8. Do you want me to go explain it from the top again? Bestie? I what? I don't know. I have no idea. That's just isn't that your flight or fight response? I don't know. I have no idea behind body uh what happens inside your body. You go ahead, sir. Okay. All right. Okay, let's go from the beginning. Let's go from the top. Let's do this again. So it says in the problem your horizontal force is 5 newtons, right? And your 5 newtons acts on this mass of 3 kg. So you have a distance of 6 meters. So you're moving this box 6 meters along a horizontal surface. And so your kinetic energy, yeah. And you're really delayed. That's why I'm seeing. Uh, type 1 in chat when you hear this, bestie. All right, I'm gonna go from the top again. Hopefully, Bestie hears this. So you apply a force of 5 newtons, right? And the mass is 3 kg. You apply a force of 5 newtons and you move it a distance of 6 meters. Now, and they want to know what the change in kinetic energy is. But you also know that since you're not moving up or down, you have no change in potential energy here. Right? You have no change in potential energy, and you have no change in internal energy because it says the surface is frictionless. So because the surface is frictionless, you're not losing any energy due to heat. So your change in internal energy is zero. And we know that to change the energy of a system, we need to do work, right? And this is the work energy theorem. So we do work and we change our total energy. And we know that the formula for work is force times distance. And so he's going to change in total energy. So now we have 5 times 6, right? And our total energy is change in PE plus change in KE plus change in Q. Okay? And then, well, we also know that since our change in PE is 0, right, you just place P 0 plus change in kinetic energy plus 0 over here. And we finally get our change in kinetic energy, which is 30. And that's the answer. I can explain that again, Bestie, if you were. I don't know how delayed this stream is for you. Usually, I think I think people's delay is like 10 seconds. Right? That's what I get when I answer questions, and then I see people respond. I think that's around 10 seconds. All right, did you get all that, Bestie? All right, Bestie, I want you to type 10 when you hear this. I think it's around 10 seconds. Guys, stop yelling. Stop. No caps. No caps necessary, guys. It's fine. Bestie, did I answer your question? I'm never going to stream with Twitch. That's not appropriate. So you're not fine with my explanation. All right, let's go. Let's run it back. Let's run it back. Let's run it back. Let's actually just erase this entire thing. No problem. No worries, Bestie. Let's run it back one more time. Let's run it back. All right, let's start from the beginning. So it says a horizontal force of 5 newtons, right, is acting on a mass of 3 kg. And you're applying that force over a distance of 6 meters, right? So you're pushing this, let's actually say, you're pushing this block 6 meters and you're applying a force to it, right? And they want to know, well, what's the change in kinetic energy of this block? So we know it's moving, so it definitely has kinetic energy. But what about potential energy? Right? Well, our height isn't changing. Our height is still 0, right? We're traveling horizontally, so our change in potential energy is 0. Well, what about our internal energy? Do we have a change in internal energy? We don't really have a change in internal energy because the question says it's frictionless, right? You're not losing any energy to heat due to friction. So I can say that my change in internal energy is zero. And now we also know that the work energy theorem, right? So our work is equal to change in total energy, right? That's to change the energy of a system, we need to do work. Right? I need to apply a force over a distance. So the formula for work is FD. And we can further break this down into change in PE plus change in KE plus change in Q. Now you don't have to remember this because on the reference table they tell you this, right? They tell you that total energy is this. Right? So the only really thing you have to remember is that, well, if you have a delta ET, then you're adding delta to everything else into that formula. So we solve this now, right? We plug in everything. We know our change in potential energy is zero because it's not really moving up. And we want to find out what our kinetic energy is, right? Our change in kinetic energy. Again, and again, for Q, we don't lose any energy because it's frictionless. So we have 30 here is going to change in kinetic energy, and that's our solution, right? Our change in kinetic energy is 30 joules. And so that's our answer. How am I doing, Bestie? I'm sorry, Bestie, that took a long time. No, Bestie, no, I'm sorry. I'm sorry it took so long. Yes, Mr. Dumani. Sure. I mean, sure. So I'll just respond to anything not academic related using chat. Someone thumbs down the video. No, I didn't. I've never played CSGO. Oh man, that's hilarious. You have any other questions, Bestie? Yeah. So number 12. So, all right. And the mass of the apple is 0.1 kg. And the apple falls and compresses the spring a distance of 0.1 meters, and that's what this x means, right? That's the compression of your spring. And so it says if all the gravitational potential energy turns into uh is transferred to the spring, right? So what is the spring constants of the spring? So when the apple falls on the spring, all of its potential energy turns into the potential energy of the spring. Well, how do we solve for that, right? Well, first off, we find out, well, how much potential energy does this apple have up here? And we know that potential energy, gravitational potential energy is mgh. And so my mass is 0.1, my g is 9.8, and my height is 2 meters. And what I'm going to do here is I'm going to round 9.8 to 10. And so 10 times 0.1 is going to be 1. 1 times 2 is going to be 2. All right, so your potential energy of this apple is 2 joules. Well, now that we know that, well, if my potential energy here is 2 joules and all of it transfers into potential energy of the spring, the potential energy of my spring now is also 2 joules when it's compressed. And now we can solve for our spring constant, right? Because we know the formula for potential energy of a spring. So 2 is equal to 1 half k point 1 squared. And then you solve for k here. And the answer is, what's the answer? 400? Yeah, 400. You can probably use a calculator. I think I just remembered the answer. About the springs thing, I get confused on what should be the x variable. So your x is always how much you compress something. The distance, so your x is change in, you know what? That's just too long of a definition. I think for you, the easiest way to remember it is that x is your change, uh, in length. All right. So how much you compress it or how much you stretch it. So let's say the spring right here, its normal unstretched length is 5 meters, and then you stretch it. Let's call it 12, and this is 12 meters now, and so x would be this, right? X would be 7 meters, because that's the distance between the stretched and the normal length. That would be my x. If you ever decide to take physics in college, instead of d used as displacement or distance, they use x. They always use x. And no matter what thing you're talking about, so this kinematics formulas would be, what would it even be? Vi. It actually be v. It actually be v0 plus, what's this, 2ax. Yeah, it'd be that. That would be the formula in college. The v0 signifies 0 seconds. Bestie, did I answer a question about what x means? I mean, the work energy theorem is just this, right? A more in-depth explanation of this is that the amount to change the energy of your system, you need to do work. So that's what the work energy theorem is, right? To change the energy of a system, you need to do work. And so if you have a pendulum here, and let's assume that there's no friction, there's no air, it's just gonna move this way, and then back again, and not really change height. Well, how do I change the total energy of the system? I do work. Maybe I slap. Maybe I slap this ball. Maybe I push this ball, right? I'm applying a force over a distance. And I'm doing work on this system. And so I'm changing my total energy of the system now. Well, if I do work on this, right? If I add energy, maybe we'll go to a higher height now. Maybe we'll go to a higher height. And come back to a higher. And so now I've effectively changed the total energy of the system. And assuming that there's no friction again, this total energy is going to stay the same. And if I want to take away energy, if I want to reduce the amount of energy, maybe I just put my hand here and stop it. Because it's simplistic. It's a simplistic thing. Yeah, you're right. It would make it stay still. But you can get it moving after the initial force. Yeah, you're getting 11 questions tomorrow. Yeah, but Rowita, the thing is, after the initial push, it's moving. Yeah, they don't because they don't say a lot of things. They say they ignore friction half the time. It's high school physics, Rowita. There are students in class that still didn't understand that when you're lifting something, that your force applied is your force due to gravity. I try to make things as simple as possible. Right? It doesn't need to get that in depth, okay, Rowita? It's not a lot of things that need to get too in depth. Mm, It's it's so that everyone can pass. You know the pass rate for New York State average pass rate for physics is 80%. At this school last year was 33%. I'm aiming for a 75. And yeah, we're finishing tests tomorrow. So if I beat that, I think I look good. I think that if I switch schools after I teach AP Physics next year, then I can just say that well I improved the physics pass rate from 33% at the school to 75%. Again, that really looks good. That looks good. But alternatively, if I alternatively if people if people take it and then they fail, that looks and then there's like a lower pass rate. Oh man, that looks bad. Bessie, you can always take the tests again. I told you, you can always take the tests again during my tutoring sessions. All I do is I change the numbers. And I remove the multiple choice, I change the numbers, subject. Like for example, the earth science class I teach is gonna bomb the earth science regions. Half of it is my half of it is like the kids are terrible, half of it is my fault because I got it in the middle of the year and I'm not really putting that much effort into earth science, teaching earth science. I should delete this video. Bestie, any more questions? As much as I would love to keep chatting, I do want to answer academic questions. I think you're done at that point. You can take whatever you want at that point, ZG. Yeah. Ask me questions. Yeah. No, I hear you. You know the delay is 10 seconds. Yeah. Click the live button. Oh. I don't think I've ever blamed myself for in physics. Have I? And in the end, it's a truth, right? Half is my fault for earth science, and the other half are the students. I'm not saying all the blame is on myself. That's not what I'm saying. I'm saying half the blame is on the students, and half is on me. All right, bestie. Come on. Question. What's the question? Let's go. I only got 10 more minutes before I just want to end the stream. Got 10 more minutes. I think the delay for you, Bestie, there's a delay for you of 10 seconds. I don't think I take too long for just just type in chat right now which question you want me to answer. I think I don't think Bestie is caught up to the current stream time. Bestie, I don't see any question. I'm about to actually go sleep, to be honest. I destroyed my legs today in gym. At the gym. Yeah, I can see you type. I can't hear you, but I can see you type, Bestie. Can you see me? I mean, can you hear me? Please just type your question. I'm Oh my, I just explained number 12. No, okay. No, okay. I'll do it again. No worries. All right. So number 12. So you have a point 0.1 kilogram apple. All right. And so your height is 2 meters. So you compress it, you compress it 0.1 meters. So if all your gravitational potential energy turned into potential energy of the spring, right? So let's first figure out what your gravitational potential energy is first, right? So at the top of the tree, the potential energy of your apple, right, is equal to mgh, and so your mass is 0.1, and your g is 9.8, and your height is 2. All right, so I'm gonna round 9.8 to 10, and so 10 times 0.1 is 1, and 1 times 2 is gonna be 2 joules. And so that's my potential energy at the top. Well, I know that my potential energy at the top is going to get transferred into the potential energy of the spring. And so, well, if we know that my gravitational potential energy goes into the potential energy of my spring, you can say that potential energy of my spring is 2 joules. Okay? So now, potential energy of the spring, let's actually just erase this part, 1 half kx squared. And so my potential energy of my spring right here is 2 joules. K, that's what we want to find out. And my elongation, the distance that was compressed is zero point 0.1 meters. And so once you solve all of this, you should get a spring constant of 400 Newton over meters. And so that's your spring constant. And if you need me, you need me to, if you needed me to explain this again, bestie, I am all for it. I can explain this again. Are you okay right now, bestie? Did you follow along? How is everything so far? Anything you don't understand? Did I explain it clearly? So you're again, we have our nodes here, and it says in the problem, all your potential energy transfers into the potential energy of the spring. So then you want to figure out, well, what is your potential energy of the apple at the top? And then you plug in all the numbers, you get 2 joules. Well, then you also know that your potential energy at the top transfers into the spring, and your potential energy of the spring is now 2 joules. Once we know this, we can use a formula for potential energy of the spring. Right, and so your potential energy is 2 joules is equal to 1 half k zero point 0.1 squared. Okay, and then you solve for k, and then k is 400 Newton meters, newtons per meter. How are you doing, bestie? You okay with that explanation? No, I was helping more people yesterday, I think. Um, bestie, can you? I can't do this. Any more questions, guys? I'm pretty sure she's just messing with us right now. I'm gonna end the stream in 2 minutes. If there are any more academic questions, I'm probably just gonna end right here. It's, I didn't give up. I think Bestie did hear me. She just messing with you guys. She's acting like an airhead. She's just messing with you guys. I'm pretty sure she listened. That's just Bestie's personality. Are there any more academic questions? I don't like Chipotle. No, I don't like it. The way ZG types is doesn't is completely different from how he looks in class. I'm not sure if I should say this because I feel like it's too inappropriate. Yeah, I'm not gonna say it. That's why I just fe- felt. No, no, no. This thing is I shouldn't say it to a student as a teacher. Right? I need to keep this clear line, clear line between student and teacher. All right. Good night, guys.